MS Ramaya University of Applied Sciences.
Hello friends, with this experiment we are determining the aggregate impact value of a given aggregate sample. Apparatus: impact testing machine, cylinder of diameter 7.5 cm and depth of 5 cm, tamping rod, 12.5 mm, 10 mm and 2.36 mm IS sieves, weighing balance and oven. Toughness is the property of a material to resist impact. Due to traffic loads, the road stones are subjected to the pounding action or impact, and there is a possibility of stones breaking into smaller pieces. The road stones should therefore be tough enough to resist fracture under impact. Impact test may either be carried out on a cylindrical stone specimens, as in page impact test, or on stone aggregate as an aggregate impact test. Aggregate impact values is as follows: less than 10% exceptionally strong, 10 to 20% strong, 10 to 30% satisfactorily for road surface, greater than 35% weak for road surfacing. Procedure: sieve the aggregate through 12.5 mm and retained on 10 mm IS sieves for standard test. The aggregate should be in dry conditions. Note down the empty mass of the cylindrical measure. Let the mass be W1 grams. Fill the cylindrical measure with aggregate in 3 layers with 25 times tamping for each layer. Struck off the excess aggregate on the top of the cylindrical measure. Weigh the aggregate along the cylindrical measure. Let the mass be W2 grams. Pour the aggregate from the cylindrical measure into the cup in 3 layers by tamping it for 5 times for each layer, which is firmly fixed in the impact testing machine. Hammer is raised up and allowed to fall freely on the aggregate. The test sample is subjected to a total of 15 such blows. Then collect the sample from the cup and sieve it through 2.36 mm IS sieve. Weigh the sample which is passing through 2.36 mm IS sieve. Let the mass be W3 grams. Repeat the procedure for 2 more samples. Aggregate impact value is expressed in terms of percentage. Calculations and observations in terms of weight of empty cylindrical measure, weight of empty cylindrical measure along the aggregate, weight of dry aggregate, weight of aggregate passing through 2.36 mm IS sieve, and aggregate impact value in percentage is performed.
Hi students, we are going on to do with the next experiment called as aggregate impact value. So first I'll explain the apparatus required for doing this particular experiment. I want 3 standard IS sieves of size 12.5 mm, 10 mm and 2.36 mm. Next, I want 1 measuring cylinder of 7.5 cm dia and 5 cm height, a tamping rod and a testing cylinder. Along with that, we want a weigh balance. Second step is sample preparation. We take the aggregates passing through 12.5 mm and retained on 10 mm IS sieve. So I have already taken some sample which is passing 12.5 and retained on 10 mm sieve. So next what we are going to do is, we are going to take up the empty weight of the measuring cylinder. Let it be W1 grams. Next, I am going to fill this measuring cylinder in with 3 equal layers of aggregates. Each layer will be given 25 number of tampings. This is the first layer. I'm placing the second, third layer. At last, I am placing the last layer, and I start giving 25 number of tampings to this particular layer. After giving 25 tampings, add the material and scoop out the excess material. Make sure that your complete thing is done, the mold preparation is done. So after making 3 layers in the measuring cylinder, pass on this and take the weight of aggregate plus measuring cylinder. Let this be W2. The difference between W1 and W2 gives you the weight of aggregate taken. Pass on the entire mix from the measuring cylinder to the testing cylinder and spread it evenly. Coming to the experimental setup, this is the aggregate impact testing machine. It's also called as aggregate impact tester. I'll just briefly explain you the parts of this aggregate impact testing machine. So these are the 2 pedestals. This is a weight of 13.5 kgs which we are allowed to free down. There is a one lock which is given to it. This is a lock. Okay, it's having a counter. This is a mechanical counter. We are going to place the entire testing unit here. So all of you know what is meant by impact. A sudden application of a load, we call it as a impact. To create the field simulation, we are going to create an impact load on this particular testing machine. As I told you, it's a lock. If I remove this lock and if I lift it, this whole mass is going to be apply an impact load at this particular point. Just look at with empty sample. If I just lift it, an impact energy will be produced on the sample. So now this testing cylinder along with the aggregates are placed on the aggregate impact testing machine. There are 2 locks for it. We are going to make sure that it will be locked by tightening this screws given over here. So now we are testing mold is exactly intact position at your apparatus. Please make sure that while doing the operation, none of you are going to have your hand or you are going to place your hand on the mold. Nothing should be done because it's going to create a lot of impact energy from this and the chance that your hand will be crushed because of the impact load. What we are going to do is we are going to lower the system and we start giving the impact load to the aggregate mass. So if I do one thing like this, this is what we call it as a one impact. Like this, we are supposed to give 15 number of impacts to the aggregate system. Now we are given 15 number of blows. We are going to lock the equipment. We are going to lock the equipment. After this, take out the impacted sample. After taking the sample from the aggregate impact testing machine, I am going to take up 2.36 mm standard IS sieve. I am going to put the aggregate onto this, which is what we call it, impact aggregate onto this. Use a tamping rod. Make sure that all the particles in the testing cylinder will be taken out, and sieve this. After this, note down the weight of aggregate which is passing 2.36 mm sieve. This is what the weight of aggregate which is passing 2.36 mm sieve. The ratio of weight of aggregate which is passing 2.36 mm sieve to the weight of aggregate which is taken gives you the aggregate impact value. As far as possible, for tougher aggregate, your aggregate impact value should be less than 10%. If it exceeds 40%, we generally call it's not a good quality of aggregates. This completes your aggregate impact test experiment.
At MSR UAS, we spark your imagination unlike any other.